A saga is a pattern used to manage and coordinate the execution of long running business processes or distributed transactions. A saga can be thought of as a process or a workflow that orchestrates the execution of multiple commands and events across different aggregates or services. It ensures that the entire sequence of actions either succeeds or fails as a whole, preserving the integrity of the data. In event-driven systems, sagas are typically implemented as a state machine that reacts to events and issues commands to other aggregates or services. Since the Nest.js CQRS package uses RxJS to control the flow of events, we can use the powerful RxJS operators to combine, buffer, and coordinate events emitted by different aggregates or services. Sagas can also represent processes that span multiple steps and might take a significant amount of time to complete. For example, a saga could be used to implement a multi-step onboarding process for new users. Each step of the process would be represented by a command and an event. The saga would react to these events and issue the next command in the sequence. The saga would even be responsible for handling timeouts and failures, ensuring that the entire process either succeeds or fails as a whole. This is why it's important that the state of a saga needs to be persisted in a database, allowing it to survive system failures and restarts. In this lesson, we're going to implement a very simple time-based saga with the business requirement that our new saga will react to the alarm-created event and issue the Notify Facility Supervisor command in the instance where 3 alarms from the same facility are created in a 5-second window. Something must be really wrong at that facility. We're making sure someone is notified. Alright, so let's get started and let's head over to our IDE and create a new Notify Facility Supervisor command class inside of the Alarms Application Commands folder. Next up, let's create a new Sagas folder inside of the Alarms Application directory. And also create a new Cascading Alarms Saga TS file inside it with the following content. Now, let's break everything down here as there's quite a lot happening. So first, you might have noticed that we're using the saga decorator to mark the start method as a saga. The start method is a function that takes an observable of events as an input and returns an observable of command as an output. The event $observable is a stream of all events emitted by the application. In our case, we're using the of-type operator to filter out only the alarm-created event events. Next, we're using the group by operator to, just for demonstration purposes, group events by alarm name. In a real-world application, also if we had the metadata field here, as we surely would with real facilities, we would ideally want to group events by their facility ID. We're keeping things simple and as real-world as we can here. Next, we're using the buffer timer operator inside of MergeMap to buffer all events emitted within a 5-second window, setting the maximum number of events to 3. Then we're using the filter operator to filter out emissions that contain less than 3 events. And finally, we're using the map operator to map the buffered events to the Notify Facility Supervisor command. You might have noticed that there's a lot of comments here in the code, as our alarms currently don't have a facility ID property. Since this isn't the focus of this lesson, we're going to skip this part and assume that all alarms belong to the same facility. You could add the metadata attribute to your alarms as an exercise though, if you want. Okay, moving on. So before we can use our saga, we need to register the saga in the alarms module TS file. Let's save our changes, head over to our terminal, and let's create multiple alarms in a short period of time. Let's switch to our other terminal window, and as we can see, the saga has been executed and the Notify Facility Supervisor command has been dispatched. Excellent. Let's try again, and now create alarms with some delay between them to make sure the saga doesn't trigger. As we can see, the saga hasn't been executed this time. Great, it's working. However, since we don't have a corresponding command handler, we're getting an error. So let's fix that real quick. let's head over to the Alarms Application Commands folder, and let's create a new file there called Notify Facility Supervisor command-handler.ts, and let's add the following code inside. You might have noticed the note we added in the code here, and this is because we don't have an email or text message service implemented in our project. Of course, in a real-world application, we would use a notification service here. In our case, we're just going to log something out so that we know we have hit this handler. Alright, so now that we have this class in place, let's register it in the alarms module.ts file. Let's save our changes, head over to our terminal, and let's create multiple alarms in a short period of time again. Let's switch to the other terminal window, and as we can see, the saga has been executed and the Notify Facility Supervisor command has been processed by the handler we just created. Fantastic. So, we already demonstrated how we can use sagas to construct time-based workflows. While this is a common use case, we're not yet merging different streams together, which could come in very handy, especially when dealing with large distributed systems. Also, joining event streams might be particularly useful when implementing compensating transactions. If you're not familiar with compensating transactions, they are the concept that transactions can potentially be reversed by processing another transaction with the opposite effect. In our case, let's look at an example just to experiment where we created yet another saga that triggers a command every time an alarm is created and it has not been acknowledged within a minute. Let's take a look and see how we could do that. Let's head over to the sagas directory and create a new unacknowledalarms.saga.ts file. And inside, let's add the following code. Now, inside of the start method, let's use the of_type decorator to filter out only the alarm acknowledged events first. Next, let's do the same for the alarm created events. Now, let's make use of both streams. So, essentially, what we're doing here is that we are waiting for an alarm to be acknowledged within 15 seconds. Note, we lowered the time to 15 seconds for demonstration purposes, since waiting for a minute would take too long. To do so, we're using the race operator that takes 2 or more observables as input and returns an observable that emits the first value from any of the input observables. If timer emits first, then we know that the alarm has not been acknowledged within 15 seconds. Also, you can see that we're using the filter operator to filter out only the alarm acknowledged events that correspond to the alarm created event that we are currently processing. We are accomplishing this by comparing the alarm ID of both events. When the alarm is acknowledged, we're using the first operator to emit only the first value from the input observable, and then we're using the merge map operator to map the value to an empty observable that never emits. This way, we're essentially ignoring the alarm created event as it has already been acknowledged. And last but not least, let's add the map operator. Here, we're simply logging the alarm name and issuing the Notify Facility Supervisor command. Note that this mapping function will only be executed if the alarm has not been acknowledged within 15 seconds, since the predefined empty observable never emits. Alright, so let's save our changes and head over to the alarms module.ts file. Here, let's register the unacknowledged alarm saga class as a provider. Great! Now with this in place, let's head over to our terminal and let's create a new alarm. But this time, let's not acknowledge it yet. Instead, let's wait for 15 seconds and let's see what happens. As we can see in the terminal, the saga has been executed and the Notify Facility Supervisor command has been dispatched. Excellent. Let's try again, and this time, let's acknowledge the alarm before the 15 seconds passes to see what happens. Let's switch to the other terminal window, and let's wait again for 15 seconds. And as we can see, nothing happened this time. The alarm has been acknowledged and our Saga didn't trigger. Everything's working as expected. Great. So in this final lesson, we have learned about what Sagas are and how we can implement them to tackle some interesting and common use cases that come up in our Nest.js applications. Also, if you've been following along and made it to this point in the course, congratulations! We have reached the end of the Advanced Architecture and Patterns course, but our Nest.js journey is never finished. We hope you enjoyed all the complex topics and subjects we dove into in this course, and hope they benefit you greatly in your future Nest projects. Also, stay tuned for more upcoming Nest.js courses on a variety of different topics, and make sure to sign up for the newsletter to stay up to date on everything Nest.js. See you in the next one, and thanks again for helping support Nest.js.